here, my path difference del x is equal to n to p minus L to p. N to p minus L to p. Okay. So, Pratish, what is my np minus lp? If I subtract np from lp, what will be my resultant? Consider this point as q. Okay. Then it will be nq. Am I right? If I subtract np from lp, I will be getting my nq. Am I right? This is the thing I want to find out. If you see here, this multiple sources I will be drawing like this. Okay. So if it is theta, question what will be this? If it is theta, what will be this angle? Very good, 90 minus theta. And if it is 90 minus theta, what will be this angle? Very good, very good. Again it will be theta. Okay. So in this case I have to find out nq. Nq is just opposite to theta. Am I right? So which in sin theta, cos theta, tan theta, which one is just dealing about opposite? It's sin theta. Okay. Am I right? So sin theta equal to opposite by hypotenuse. So what is my opposite here? What is my opposite to this theta? It is nq. Opposite to my theta is nq. So nq, what will be my hypotenuse? Yes? L. My hypotenuse is just lq. Ln ma. If you look at this is my right angle, am I right? Making 90 degree. So this is my hypotenuse. So my hypotenuse is just this A. Am I right? The distance between the slit from the cardboard. The width of the cardboard is A. It's not the distance between. The width of the cardboard is A. So if I want to find out what is my nq leave as it is, I have to find out nq. What will be my ln? A. Very good. So if I want nq, can I bring a to the opposite side? Yes. So it will be a sin theta. So my path difference del x equal to nq, that is equal to a sin theta. Successfully I found out my path difference. What is my path difference? Del x equal to a sin theta. Again, for small angle approximation, we have to do small angle approximation. Am I right? If I do that, sin theta is approximately equal to theta. So my del x is equal to a theta. Is it clear to everyone? Yes. Then so now I am going to discuss about that conditions for maxima and minima in case of diffraction. Okay. That maxima will happen and where minimas will happen. Okay. Maxima is your bright fringe. Okay. Constructive interference. Minima is your dark fringe. Destructive interference. So condition for maxima. Yesterday we discussed my del x equal to in constructive interference del x is equal to Pragadish. What is my equation? Del x equal to L lambda. Can I equate my general equation for constructive interference to my particular case for this diffraction? Yes. Can I compare these two equations now? Yes. So my n lambda will be equal to a theta. Am I right? N lambda will be equal to my a theta. So what is my resultant equation? How can I change this equation? Yes. Yes, very good. Theta equal to n lambda by a. So for small angles, my theta will change into n lambda by a. For this is for minima. the maxima and minima equation, the equation for constructive interference and destructive interference will change totally, will reciprocate themselves in case of interference and diffraction. Okay, whatever the equation you are dealing with for constructive interference in case of interference, that will be here for destructive interference. The equation for destructive interference in case of interference will be the case of constructive interference in case of diffraction. So this n lambda you are equating, and this is for destructive interference in case of diffraction. So condition for maxima in case of diffraction, I know my equation for destructive interference is del x equal to n plus 1 by 2 into lambda by 2. If I compare this with my equation for diffraction,